Find the value of a, b and c so that the function fx is equal to sin a plus 1 into x plus sin x divided by x when x less than 0, and that is equal to c when x is equal to 0, and that is equal to x plus bx square root minus square root of x divided by bx to the power 3 by 2 x greater than 0 is continuous for all values of x. So in this question, there are three functions. One is for x less than 0, another one x is equal to 0, and the third one is x greater than 0. And we have to test the continuity of the function for which value of a, b and c, these three functions will be continuous. And let us check the continuity of the function in terms of limit. And as you know, in terms of limit, we can check the continuity of the function. Number one, if fx has to be defined at x equal to c, this is the first condition to test the continuity of the function in terms of limit. Fx, the function has to be defined at x equal to c, and this condition here is given because the first condition fx is equal to c at x equal to 0. So at x equal to 0, the function has been defined. That means limit of fx at x approaches to 0 is equal to, suppose f0, that is equal to c. So that is equal to c, it is given, and we have to find out what is the value of c. So first condition is satisfied, and the second condition is in terms of limit of fx x approaches to c is equal to fc. For that, we have to find out the left hand limit and then the right hand limit, and we will show that the left hand limit is equal to right hand limit. That means if the left hand limit is equal to right hand limit, then limit of fx as x approaches to c is equal to fc. Using this condition, let us check the continuity of the function. The limit of fx x approaches to 0 minus, we have to check the continuity at x equal to 0. So we have to first check the left hand limit. For left hand limit, we take x approaches to 0 minus, and the given function is sin a plus 1 into x plus sin x divided by x as x approaches to 0. When x approaches to 0, we take a value which is slightly less than 0. Suppose you take a value h, which is a very small quantity, and slightly less value than h, then 0 is 0 minus h. So you substitute x value is equal to 0 minus in this function. So the function will be equal to sin a plus 1, and in place of x we substitute 0 minus h, plus sin in place of x we substitute 0 minus h divided by x means 0 minus h, and h approaches to 0. So this will be equal to sin a plus 1 0 minus h, that is minus h, then sin 0 minus h, this is also minus h, divided by 0 minus h. So this is equal to minus h, and we have separated the two terms. The first term is sin a plus 1 into minus h divided by minus h, and the second term will be sin minus h divided by minus h. And we know sin of minus theta is equal to minus sin theta. So this will be equal to minus sin theta in the numerator. So minus sin theta divided by minus h. So this will be equal to sin theta divided by h. So the second term will be equal to sin limit of sin h divided by h approaches to 0. And the first term, this one will be equal to limit sin a plus 1, here h cancels, and here we have multiplied a plus 1 in the numerator and a plus 1 in the denominator. So this will be in the form of sin limit of sin x divided by x approaches to 0. We know the value of sin limit of sin x divided by x approaches to 0 is equal to 1. So this value will be equal to 1. So the first term will be equal to only a plus 1, and this term sin x divided by x approaches to 0, this term also will be equal to 1. So the result will be a plus 1 plus 1. A plus 1 plus 1, that is equal to a plus 2. So you have to remember these things. You have to remember this formula, that is sine, limit of sine x divided by x approaches to 0 is equal to 1. And you have to also remember the formula sine of minus theta is equal to minus sine theta. So from the left hand limit, it is equal to a plus 2. Now let us calculate the right hand limit. To calculate the value of the function for the right hand limit, we take the x value, x approaches to 0 plus. So limit of fx, x approaches to 0 plus, and the given function, as we have, it is given that for x less than 0, you see here, for x greater than 0, the function is x plus bx square root minus square root of x divided by bx to the power 3 by 2. So this function we have to take for x greater than 0. So here we have taken the function, you see here we have taken the function x plus bx square root minus square root of x divided by bx to the power 3 by 2. And here we will take the value of x is approaches to 0 plus, that means 0 plus a small quantity h. So you substitute x value 0 plus h. So here you substitute 0 plus h, here also you substitute 0 plus h. So the result will be limit of 0 plus h plus b into x square, that means b into 0 plus h whole square minus square root of 0 plus h divided by b into 0 plus h to the power 3 by 2. So the result will be 0 plus h here will be equal to h, and this quantity b h square, 0 plus h whole square b h square, this term will be equal to square root of h divided by b h to the power 3 by 2. And if you take h to the power half common in the numerator, and in the denominator also you have h to the power half, and they cancels. So the result will be limit of 1 plus bh minus 1 divided by bh, h approaches to 0. Now you multiply 1 plus bh square root plus 1 in the numerator and 1 plus bh square root plus 1 in the denominator. So in the numerator you have the relation a plus b into a minus b, that is equal to a square minus b square. So in the numerator you have 1 plus bh minus 1, in the denominator you have bh into 1 plus bh square root plus 1. So 1 minus 1, that will cancel, and bh, this will also cancel. So the final equation will be limit 1 divided by 1 plus bh square root plus 1, h approaches to 0. When h approaches to 0, in the denominator you have square root of 1, that is 1 plus 1, 2. So the right hand limit will be equal to half. But we know for fx to be continuous at x equal to 0, the left hand limit is equal to the right hand limit. And from left hand limit we know the value of the left hand limit is a plus 2, and the value of the right hand limit is half. So a will be equal to minus 3 by 2. So in this way you can find out the value of a. And we know left hand limit is equal to right hand limit is equal to the value of the function at x equal to 0. That is why from right hand limit we get the value of value is equal to half. So c value will be equal to half, because the right hand limit value is equal to fc. And b can have any value, since there is no b in the equation, so b can have any value. So in this way you can calculate the value of a, b and c, so that the given function will be to test the continuity of the function at the given conditions. Thank you.